Okay, hello everyone. Today is November 3rd, and welcome to the Lifecycle working group. First, would like to anyone introduce themselves?
Yes, hello, my name is Martyna. I am from the GKE Cluster Autoscaler team. I am first time on this meeting because I have the topic of the node conditions and just wanted to ask you around whether you are planning to introduce something new or not, so we can maybe somehow align.
Yeah, sure. Thanks for coming. Yeah, and we have been discussing these topics recently, so any new feedback is welcome. Okay, so first we have one announcement. We have a session at the Maintainer Summit in Atlanta with Ryan. So like if anybody's there, feel free to come. And also I'm gonna ask if anybody's on KubeCon and or you can just share it here, or you can ping me on Slack and we can think of something else as well.
It's I'll just add it's the first session. So it's I don't whenever it's on Sunday. So the first session on Sunday, so it's gonna be in the morning. So I don't know when people get in, but it's just something to think about.
Yeah, we sadly don't have a session like in the KubeCon session as well. Like as it would be great. Like it's great to also have the Maintainer Summit one, since we can get more feedback from like the Kubernetes contributors. But yeah, we also would like to reach more folks, like to get like general feedback from the users. Okay. Yeah, so as I said, like you can ping us, me or Ryan on Slack if you want, and you are on KubeCon, and or you can use the our working group Slack channel then to sync up. Okay, so the next topic today is it's how do we tie together eviction request cap and graceful node shutdown cap together. So we don't have Lucy here, but I guess we can just roughly describe that. So let me first share the screen.
Sorry, you are muted. We cannot hear you.
Oh, thanks. Yeah, so the eviction request cap is focusing mainly on like pod termination / eviction. So it's not like directly connected to the graceful node shutdown. So we like the cap itself is not improving that like by itself in any way, but the follow-ups might be useful to help the graceful node shutdown. So like the first thing is like we might like improve like the termination of the pod, or by using the eviction request under even some like some option, or by default that should basically that would have to be discussed in an additional cap. But the main thing how we like plan to improve the graceful shutdown was through the non-maintenance cap, which is basically this one, and through the non-maintenance API. And this is basically similar like API meant to replace like the kubectl drain and similar drain behaviors like in other projects, which some of them are like importing the kubectl drain as a library, and some of them are implementing like the eviction loop themselves. And this is still like very early stage work in progress cap. And one of the fields we added to the node maintenance was a drain plan. And this was basically modeled after the graceful node shutdown, since the graceful node shutdown has an option to basically evict pods according to their priorities. And we are using like a similar system here. Like this has a lot of room for improvement. So as I said, it's not a final stage. Like the types of ordering we might have might differ in different scenarios. But like the original plan was to have like this declarative API that would basically solve how to basically evict all of the workloads from a node, and it would it would basically offer this API that other users could use. So for example, also the graceful node shutdown. So it could basically communicate through an API object, either as an implementator of this API. So it might basically could implement this behavior and just do what it is doing currently, or it could just create a non-maintenance object and let the controller basically do evict all the pods and use all the like different like orderings to do that. And like one of the problems we face today is that the graceful node shutdown is not observable. So if you like we detect that like a node is shutting down, like kubelet kicks off basically the eviction according to the priorities, but it is not observable from outside. So you don't know like which kind of pods are being evicted at what time. And this can cause issues. So we still have an unresolved issue regarding the daemon sets, that basically there is like a race loop of pod creation and deletion, so or termination, not the deletion. So the pods basically are terminated by kubelet, but are immediately replaced by daemon sets. And some of the daemon sets like might be of like a higher value. So like we cannot just solve this by a boolean. So like anytime like a kubelet would start terminating, so for example, it would start with like the lowest priorities and just kill off all the like normal workloads. And if like a daemon set would pod crashes during this time, and it's not like it's not like it's not meant to be terminated, it would basically hold the services that it is offering on the node. And yeah, we would like to prevent this scenario. So this is basically what we like designed. And as I said, there is a lot of room for improvement. And the node maintenance, declarative node maintenance API would like to use the eviction request API in background. So it would offer like a better kind of eviction or more graceful termination. And we are also designing the eviction request API to offer like different kinds of termination logic. So like we would have to figure out how the graceful node shutdown would like this to be implemented, because it might not be feasible in all scenarios to offer like unlimited protection for pods, where we would basically wait like even days or like for workloads to be terminated. So it also, as before, depends on the scenario, and we might offer some kind of like deadlines for termination, etc. But yeah, as I said, this is still like to be planned. So yeah, does anybody have any questions? I suppose we will
I,
get them later once
I can
Lucy.
ask.
Yeah, go ahead.
Yeah. Well, was so one of the cases I was thinking of with the graceful mode shutdown, and I don't know if this is what I don't think this is what you're talking about, but the one of the really hard ones I think was the issue where like the kubelet restarts while we're doing graceful node shutdown, and we lose track of like what's happening. And I think that was one of the cases where so like I think when I was listening when you were talking about this is the case where we sort of ahead of time we said we want to shut down. Mhm.
Yeah, so this is like one of the issues we would like to solve. So like today there are I think there are like scenarios or even like bugs where you basically can lose the shutdown signal. And so there are basically two options. Either you are like properly restarting the node and you expect the node to come up at a later time and start all the pods again, or you lost the signal and you still expect like the pods to be drained and node to be like restarted or decommissioned. And we would basically have to solve like the ownership of this like declarative object that's tracking all of this. So yeah, this is for like a cap to this to be decided. But basically, we would expect like the kubelet to create this um, object, and or like during the node shutdown, and like the entity who is like restarting the node or is marking the node as like schedulable again, then it could remove the maintenance or and remove like the declarative object.
Okay. Yeah, this is you so you think that the declarative node maintenance object in the case would so this would include the case where like things go wrong on the node. Like there's we just this is like our this is the object that would track it's the state of the node.
Yeah, true. Yeah, so like there has to be something which like allows like the node to be like back ready in the cluster. So like we this object is just used for like the communication of the intent to like uh, like shut down the node or like evict all the pods from the node.
Okay.
Yeah, I know this has like a lot of implications for like the real node shutdown and termination or like the VM life cycle, like where this is running. So yeah, there is a lot of things like to be thought of at this end. Yeah, I see we have Peter here. Like, do you have any thoughts on this?
Sorry, I was paying half attention.
Yeah, so yeah, that's fine. So I mean, what are your thoughts on like either like because this would be like adding like new features to the graceful node shutdown, either that it would create like a new declarative objects and the graceful node shutdown would control these objects, or it would hand over the control to a controller. So do you see like do you feel like it would be feasible to uh, basically change the beta of the graceful node shutdown feature, or like to add new options that would basically solve the current problems of the graceful node shutdown?
Yeah, I definitely think adding a new option is allowed. I mean, like we could do that even if the feature was GA. And like there is some precedent, like in the swap world, we had when we were enabling swap, we had the unlimited swap option that we later removed and changed to limited swap, and that it was in beta when we removed it. Basically, we didn't do it in a super graceful way, and I don't think we should do it exactly like that. But we do have some precedent of like learning that we made a mistake in the way that we were implementing something and then pivoting in beta. So I definitely think that we could do that. Specifically, who should be owning it? I mean, at the end of the day, the kubelet does have to react to it because, you know, it's the one that's setting the, you know, it's actually talking with system D about things. So I don't necessarily think that the kubelet should be, I think that an external controller probably could make sense here, but like we will have to extend the kubelet to be able to understand the new, you know, whatever new constructs we have, we're creating to make sure that it's talking with system D correctly. But I definitely think we can do that within the beta, especially because Graceful Node Shutdown is like fully blocked on this anyway. So it's not like it's going to go GA without us answering these questions. So I feel like Graceful Node Shutdown moving forward is actually really contingent on us figuring this out.
Okay, yeah, sounds good. Yeah, I think both options are fine. Either like adding a new option or just changing, which, like as you said, would not be maybe feasible. But I mean, the graceful node shutdown is still like under beta, so like users are expected to enable it. So if we say like there is a better way to like do graceful node shutdown and use this feature, then like we could still it could still be like very useful to most of the folks.
Yeah, and I think we can and like go through the deprecation process of the old way of doing it eventually too. Like I don't think we need to carry both forever. If the API or if like the way that if there are specific knobs that we need to enable in the kubelet, or we need to like move away from the old way of doing it, I definitely think that there's room for that.
Okay, yeah, that sounds promising. Like if we like make a progress with the node maintenance, that I think it would be better because like one of like I mean kubelet can still could still like be the main like contain the all of the logic for the eviction of the pods or like the I mean like the processing of all the priorities and other types of pods. But I mean the advantage of like this external API in the controller is that we would have like a reusable uh, or one entity implementing this, and other folks could just offload their logic to this. So kubelet could just like ask for these pods to be removed, even though the kubelet is removing these pods itself. It would get like a signal from above, like which pods are ready to be removed and under what conditions. But yeah, this is still like long in the future. So these are just like ideas that we are experimenting with. And yeah, and so like this release, we focused mainly like on the eviction request cap, which uh like we made some progress on that, but it was still not we did not get a consensus in 135. So we will try to reach consensus in 136. And in parallel, we are also trying to work on the node side and the node maintenance and the node states, which like Ryan is mainly focused on.
Yeah, what if I want to add that I think there's maybe, at least the way I look at it is I feel like there's sort of two parts to this. There's the we have the declarative node maintenance, which is like I think we're looking at it as an API that will help us manage the node lifecycle. You know, specifically like maintenance goes through several the node will go through several lifecycle states. And then we need a way to observe those changes on the node. And I think that's sort of the other aspect of it. Is like when we go and we make a change, like we would like, what's the node state? What is its current condition in the life cycle? So kind of like, at least the way I look at it is I feel like these things are tied together. Um, and then the eviction part, right, is the other part, which is that's the request to say, okay, well, now we've reached a certain stage in the life cycle, specifically draining, and we want to execute on, a drain plan.
Yeah. Like when we are talking about these states and the node maintenance API, I think one important point is to discuss like the extensibility of these APIs. So like as we saw, we had like a couple of presentations from a few companies to see like what they are doing about their node lifecycle and the cluster, like how they are basically maintaining their cluster and their nodes and what their processes are. And we might not capture all of this like need for like a common logic or APIs in the node maintenance cap. So we have to think how like this, how we can make this extensible for folks who have basically their own other like more advanced tools for their like specific needs. And like with this, and the second part is like we have to think about it, but on the other hand, like it's very hard to like bring the extensibility like in the beginning to the table. So I think like it might be better to start like with like a kube centric, or I mean like Kubernetes/Kubernetes centric like logic, and like have like extensions points where like we could add to them later. But yeah, like what do you think about the extensibility, Ryan?
Yeah, I think I think that's important. Like you said, I think, or maybe the way I'd put it is that I think there's like this declarative node maintenance. I think it's sort of like a building block for a larger ecosystem of doing node maintenance. I think there's like, we want it to be like an API that is useful, and I think that maybe we'll have I think if we design sort of a bare bones system for it, it'll be generally useful, and I think sort of I think there'll be plenty of room for it to expand, and I think the ecosystem itself is really where the value comes in. So the work that sort of comes on top of it. So I think if we design it well, I think, and we really hit the really fundamental states for it and its usability, then I think that's where the value will be, is the things that people can build around it. So I guess one way of saying it, the extension points, I think, like you said, it will come later.
Yeah, that's one thing I forgot to mention. Yeah, we for sure like want this to be a building block, so we are not planning to add like many features to this in terms of like auto triggering node maintenance under some scenarios. I mean in general, like not the graceful no shutdown feature, but uh, yeah, basically improve like the drain plan, or I mean the way like the node maintenance progresses, but leave like the other interactions or integrations on other like on higher level tools. And yeah, and we probably should like try to accommodate like the needs or extensibility like with additional features for these APIs, for the declarative node maintenance APIs. So once we release an alpha, we can ask for feedback and see like what people are doing, and then we can enhance the API like that in a way that it works for everyone. And like at least in the beginning, I would like to prevent like for example, to have like an option for this API to be owned by like alternative controllers. So for example, the thing like we did with the job API, which has like a managed by field and basically you can override all the behaviors like by like a different out of core implementation. Because then it is much harder like to evolve the API and basically like ensure a conformance of this API. Because you can have like other controllers and you need to have the API very tight and make sure that the other controllers are, since this is a building block, it will depend, like everybody would depend on it, and other controllers could basically like disrupt these flows. Okay. Yeah, as I said, like these are very like conversations for the future, since this this will resolve in like future releases. Okay, Ryan, do you want to take over and look at the SLM?
Yeah. Would you be able to give me permission to share, please?
Yeah.
Thank you. Okay, I got it. Thank you. Okay. All right, let me get set up here. So the topic was about this creating a KEP for specialized lifecycle management. I mean, I feel like we're at a point where it would make sense to at least publish this outside of this document and start talking about it a little more widely. I think so. Like I said, I think the topic here of specialized lifecycle management sort of is spanning like several concepts that we want to do, and generally around the lifecycle management of different components. And I think this concept, at least the way I'm proposing it, is like the focus would be on the node and sort of how we can improve the node's lifecycle. So I would like to propose this as a KEP. I think the sort of the structure of it, I think is good and in place. We have use cases, and I think there's probably even more we can expand on. But I mean, pretty much like the thing that I would need to change in here is like I would need to write like a little bit more of a design aspect of it. At this point, we've been sort of talking about it, these conditions as sort of just in this diagram. But I think like I think what it makes sense is for this to go through the next stage of and sort of grow into a KEP. But I wanted to get some feedback on that though, if people feel differently or if we need to have anything specifically that we should have first before we talk about doing that. Is there any comments about that?
Yeah.
So I have one question. Sorry, I'm not very familiar with already existing node conditions, but some of them definitely for sure exist. Does this table gather already existing node conditions, or do you introduce some new ones in it?
So there are several node conditions, and the proposal is about adding several new ones.
Which are new? Yeah.
Oh, which are new? These right here, the ones I'm highlighting.
Okay.
Yeah, this one. Yeah.
Uh-huh. So I don't want to, like, because I don't know how much you will spend time on this table. So I will quickly ask, is there any node condition which reflects the state when we are unable to scale down the node because of some reasons? Maybe there is some pod that we cannot evict or something. So basically, the fact that scale down is blocked for this node, because we are getting a lot of customer issues asking for some source of observability with the justification why the cluster is not being scaled down.
Okay. I think so I think so we don't have a condition for that. I think that's the short answer, is that there's not a condition to say like
Okay, and
this can't be scaled down. But I think
okay,
there's
and
go ahead. Yeah.
so I just wanted to, because we are thinking about adding one to address this tons of requests with like, asking us for the explanation for that. And the question is whether you want to align it somehow, or can we just add it as a separate one, just like CCing you in it? Because I don't know how you want to, like, align all those new conditions with the only one that we are interested actually to introduce.
So I would need to understand the use case for this one. So I think what you're getting at is this is when you have a customer who they want to prevent a node being drained. Is that what
No,
this
not
is?
prevent, not prevent. This is totally opposite. So they do not understand why the node is not being scaled down.
Oh, okay. So they don't. Okay, so it's not for preventing. Okay, so it's
Yeah,
so
it is
this.
not about, this is the opposite. I would say the most common case is the opposite one. So they do not understand why they need to pay for the node, because they would expect from us, meaning cluster autoscaler, to remove it. But we are unable to remove it due to some conditions. And we wanted to basically somehow, like, put the justification, like why we are not doing it. And
So
obviously,
I.
like,
Oh.
mhm.
Yeah, well, I'm sorry to interrupt you. So I guess what I would say is like I think what we're looking to accomplish as a part of like these node conditions is like we want to model like the full like the full node's life cycle, and that we want to see like these are things that we want that we expect like the node to be undergoing some kind of change, I guess is the way I'd put it. um the node is changing in all of these different states when they're kind of moving between them. And then I think like maybe what I would say is about the condition that you require is it sounds like that the customer is requesting essentially that they take the node away, right? But it's not that so they're requesting a change, but it's being blocked by something else. It's not sort of being blocked by a node. It's being blocked by some sort of workload, right? Is that correct? It's like something else is. It's nothing to do with the
Yeah,
node.
it is not necessarily by always by a workload. It might be that, like, you reach the mean size of the node group or something. Yeah, so there are different reasons for that. Not necessarily always the workload.
Okay, so
Uh,
maybe I could let me see if I can convince you of different maybe like talk about different or related ideas. So if you were to say, let me just put it this way. So let's say you were to say the customer's intent, which is that they would like to drain this node, right? They want it gone. They think it should be gone, right? That would be their intent. Would that be accurate?
yeah, they would like to understand if it is not able to be drained, why is so. But yeah,
Okay.
it is
So
about.
but their expectation is that it should be draining, right? It should be draining.
Mhm.
Okay. Yeah. Okay. So so the way I would I think the way that you could model it here is that is that they have an expectation that it's draining, So what I'd expect is that like the node is going through some change. The change is that workloads or something is leaving. And so I guess the way I'd model the condition, so the way at least we're modeling the condition is that it's draining. And so like maybe to solve your use case is that if we had some way to do that, like if we were to say that the node is undergoing this change, that it's supposed to be draining, and that could be bubbled up to the end user. And you could always have sort of we have these, like we've been talking about some APIs about like Philip was talking about, where we're talking about the eviction request where things are blocking it. Like we have a plan for how we should be evicting things. There might be ways or like hooks that we can plug in for informing users as to, okay, well, this might not be why it's successfully able to drain because we haven't evicted this workload.
Yeah, but there's one additional thing. So because there is some new controller, yeah, that will be owning this new node conditions, or because typically like there's like one owner who is setting the conditions to avoid races. So the conditions that you are introducing will be modified by which controller?
So this is where I think where we need to tie in some pieces. I think like we were just talking about the node maintenance cap. I think the goal would be that we would use this node maintenance API to help us control these different states on the node. So there's a diagram here. I mean, this is kind of how, so I just call it a maintenance API. This is the node maintenance cap, has different states. And then the idea is that it could control these different conditions on the node, and they get recorded on the node.
Okay, but it is not existing yet. Yes, it is like
no, it doesn't exist. Yeah, you're early.
Okay.
Yes, yeah, it doesn't exist. No.
Okay.
This is how we're thinking about it. So this is about, so this discussion is about like a cap. There is a cap for the node maintenance API. There's not a cap for these conditions and sort of creating conditions on the node. So that's what I was proposing, is that I think, it would be good to have a cap for this and starting to try and work this into the community.
Yeah, it would be great. I think also in the terms of aligning, like, the other ideas for the conditions. So
I would love to hear if you could take your use case, I would love to have it in here, because we kind of talked through your problem a little bit, and I think
yeah,
it would be great to have to talk.
Yeah, definitely.
Go
It would
ahead.
be great to have a talk, but for us, as I mentioned to you, the main use case is like the observability. So for us, it is not enough that there will be some conditions set to true or false, because the customer wants this message, this whole node, basically, and this is the most important part. So either this API would need to allow to also pass this whole message. Either we would need to set this node condition from cluster autoscaler, so this component is the owner of this particular node condition.
Yeah, can I steer this conversation a bit differently?
Sorry, I stole it. Sorry for that.
No, not problem. It's a very good feedback. So yeah, I think first, you have to, as you said, you have to distinguish what's the reason of the node, or the drain being blocked. And one of the main reasons are that some of the workloads have, for example, PDBs, or are unable to be terminated, or as you suggested, there is also some pre-assessment of the drainability of the node by cluster autoscaler, that it knows beforehand, before it does the drain. And this also ties to the observability, who has the information of what is basically wrong, and how we can tell the users. And so this is the observability is one of the missions of the eviction request API, and the declared in non-maintenance API. And it would, like, for every pod, you would basically have an eviction request object where you could see like who is interacting with it, like some interceptors that are adding some additional logic to the pod termination. And if there is no interceptor, you can also see like the number of like eviction like like the normal eviction requests that are present today in Kubernetes. How many eviction requests like we actually did against the like the eviction API. And if it is blocked by a PDB, you will see the counter like increase, like for example, 10 in the last, I don't know, X minutes. And like the user could actually see like like for how long this is being like retried. And it can basically debug like what kind of pod this is. And if the pod is not cooperating like with this like eviction, like we can suggest like to the owner of this pod to actually implement an interceptor that could basically monitor this pod and monitor what it is doing, and could add like additional logic to basically resolve like the PDBs or like the disruptions, like as there can be like multiple different scenarios for disruptions. So for example, you could outscale a pod, or you could scale up the pods, or maybe you are even running pods across like multiple clusters, and you can actually observe that, and you can react to this API. So the like the observability of the pod itself, or of the eviction of the single pod eviction, should be solved by the eviction request API. And then you have like the node maintenance API, who is basically a set of eviction requests. So you could have like a you know you could have like a summary of all the like eviction requests that are in progress and that will be in progress. And you could see, for example, how many pods in the cluster, or on which node on a node are like progressing. We will have also ETAs, so you will see like what is the expected time, like when this should complete. And so you could basically observe like this higher level view in the non-maintenance API. And we would basically like to write through like even like a more distilled summary through these conditions to a node. So on a node, you could see that maybe we are like the maintenance or the draining is in progress, and you could like back reference to the non-maintenance object, and then you could also drill down to the eviction request API, and it all should be like tracked in like etcd, so it's observable, everybody can see it, can see the progresses, all the actors that are interacting. Yeah, so like these conditions are like the highest level like of like that's like a simple user just looks at the node and it sees like what it is doing, like that's maybe it is draining, but if you want to know the details, you should always drill down. Yeah, but now it comes like back like to what you want to do in the cluster autoscaler. And so like we still like need to work on our adoption story. And we would love to, for example, if cluster autoscaler would use the non-maintenance API, so they basically could like remove the eviction loop you have in the cluster autoscaler. Like I know you have also like a bunch of toggles, like what it should do. And like we would have like a solution that like as I was telling before, for example, the graceful enough shutdown or even other drainers would use, and you would have like a same approach to draining. So like from autoscaler perspective, you would create the non-maintenance object, and then it would be taken over by a controller that would do all the eviction loop, and you could observe like node maintenance, how it is behaving. And maybe we will have like more features in the future, and there will be more toggles on the node maintenance, but for now we hope to make it simple. But yeah, I don't know, I went a bit on a tangent, but I hope it makes more sense.
Yeah, but for us, I think like it is kind of like, important what is the timeline of this effort. So do you have any specific like at least rough estimates like when do you plan to implement it somehow? At least some part of it?
Okay, so yeah, we hope to have, like as I said, more conversations on at KubeCon, mainly about the eviction request API, since this is like first in line, and hope to get more consensus. And we would love to like contribute it in 136, so next release. And yeah, so like like stay tuned, like what to see like what our current conversations how they like end up, and if we get the consensus like also from all the like kube and maintainers, since like this is like a major API and it has major implications. So like I cannot promise you that we will have it in
Yeah,
136.
but it is more about like, the at least the what are your hopes and visions, like how do you plan to work on it, and like, about your capacity and stuff like that. Yeah, I don't want to steal more of your time. I will go through the doc, which looks very cool, and if I have more questions, I will probably come to one of your next meetings.
Yeah, totally cool. And yeah, and just keep in mind, for example, the declarative non-maintenance API or CAP has not been touched for some time. So we hope to like revitalize that and basically look into that soonish to basically keep bring it up to date. And we hopefully should have more consensus after KubeCon what to do. And then like once we have the eviction request, we would like to follow up with the node maintenance like after that, and with the node conditions or the SLN. Yeah. I think I forgot one thing. Sorry. Wait, you can go ahead.
Yeah. Okay. Was there questions? Well,
Yeah, I remember. Sorry. And like once we have the eviction request API, even though the node maintenance cap is like would like to use it, so basically it would like to replace the kubectl drain and like to use like eviction requests instead of evictions. Like we still don't have like any estimate how long the declarative node maintenance would take. But in the meanwhile, like other projects like Cluster Autoscaler could use like the eviction requests like as a as a replacement, like instead of like the imperative evictions which are in use today. And it could basically solve a lot of issues for like users having like special pod life cycles and special like PDBs that are like basically your users running into when they have the drain is blocked. So we could alleviate these problems like for like a bunch of users until we get even to the node maintenance API.
Yeah, but like, we have very tight dates when it comes to all the observability stuff right now. So yeah. All this new eviction API is like something totally separate, I would say. And unfortunately, like at least my team is currently focusing on observability work only. Yeah, but it's definitely good to know that something like that is happening, and yeah, unfortunately, it is not necessarily in scope of what I am assigned to like look into.
Yeah, I understand. Like, yeah, I know. Like, but even if you like want to focus on the observability, there is like this hard problem of knowing like what the applications are doing. So like I know, like for example, from the cluster autoscaler standpoint, like you have some like heuristics to like know when the drain is blocked, etc. So that could be useful in the meantime before we even have the evasion request. So
yeah, I will look into that because I don't know and like much details around that. So yeah, I will look into that, and yeah, maybe it is also something worth consideration.
yeah, I think like the distinction is what we are trying to do with the evasion request is basically to bring the responsibility back to the application. So the application like tells you what it wants to do, or how it should, how it would like to basically migrate or be removed from a node. And but this is, it's a long adoption story. So like sure, like I think it's useful to have like rough solutions before this comes to life. But I think, as Ryan said, like having your feedback in the SLM would be also useful to like help us with the design. What should like be available, like, or as like what kind of APIs or best practices we can bring to the users later.
Yeah, I think in our discussion, like I was talking about just one state. This is an example. I mean, this is why I was hoping to get some feedback, because perhaps this doesn't meet your demand. So that's why I wanted to see if it did, like if this makes sense. But it would be great because you talked about observability, which we have as one of the requirements, and sort of we're tracking node state. I think it would be great to have there if you could have your use case. I think it's certainly something we want to touch on. Observability certainly is a big part of this. I think a big part of like all three of these caps is observability.
Yeah, and the fact, as I mentioned, like for at least what we are getting is why the node is not being scaled down. This is the most common question, I would say, in that area of nodes from the cluster autoscaler perspective.
Okay. Yeah, thanks for sharing. That would be great. Yeah. I think, yeah, if you can add a use case, that'd be great. I think we should continue the discussion. Okay, I wanted to go, JP, you had some questions. I wanted to see if we can address this really quickly. Do you want to talk? I just because I don't want to misunderstand. Like, is it you wanted to look at these?
No, sorry, can you hear me?
Yes.
Okay. No, I would say that the most important thing for us as a community is to go through these with the new use case. So for what I mentioned in the chat was mainly for Martina. I'm sorry if I'm mispronouncing your first name. It was to make sure that if there was something that you had in mind, maybe the fact to phrase it here as a potential additional node condition proposed could be helpful. So not only explaining the use case, as you mentioned, Ryan, but also here rephrasing it as a condition that would be applied on the node could be useful for us. I believe. It was just that.
Thanks for that comment. Yeah. I will try to gather what we had as a proposal, what we needed, especially for our use case, and let's try to maybe somehow find the common ground.
Awesome. Okay.
No, right, and I don't need to go through that myself. It's fine for me. FYI, I've started to do a proof of concept on QOD to use those, and to see if that would be something to show in a future date to see how it could actually work and how it could be usable by other controllers. So
awesome.
That's for the future. Yeah.
Okay. Thanks, JP. Okay, that's great. Okay, thanks a lot for that. Okay, we've got 1 minute left. So the original question I asked was about a cap, creating a cap for this. I mean, would anyone like to talk about like what would we? I mean, besides following the KEP process and meeting the requirements of the KEP, is there anything else that we should have or do here for trying to go and create a KEP? Or do we feel like this is at a good place that, like maybe with a few more details, I'm gonna have a few comments on the side that need to be addressed, but with a few more details, trying to go and create a KEP for this.
Yeah, to me it seems like we can open the KEP. Like there will still need to be like a lot of iterating in the KEP until we get like to like a more ready result. So yeah, I'm all for opening the KEP and like see what like where we get.
Okay. All right. I think
Yeah.
might be all we all have time for. Okay. Yeah. Thank you very much. I guess we'll just go ahead, Philip, if you want to close it out since you're the host. I think we'll end with. For me,
Yeah.
I'm good with that.
Yeah, thanks for that. Like we will need more collaboration on that, and as we said in the beginning, like next week is KubeCon, so we will cancel this meeting and hope to see you in 2 weeks. Bye.
Thank you.
Thank you. Have a nice day.
Bye-bye.
Enjoy KubeCon.